Welcome back to Shades of Green Radio Show on KDWN 720 AM in Las Vegas. Our show is produced by Green Alliance of Nevada, sponsored by NV Energy, and I'm your host, Stan Hanel, with our producer, Annette Bubak, in studio today. Great. So our theme for today's show has been, we're taking kind of a little dive into some of the jargon and terminology and measuring units that are involved with electricity in some of the industries that we talk about with our guest speakers. And we're talking during the break, we don't always think about how that comes to us 24/7
Exactly.
every day. Yeah.
Yep. In fact, it's fun hearing you even mention the fact that you throw the switch on and things just work. And I believe, our generation, we've always had electricity. So we take it for granted a little bit as to how it gets there, what it's called, all the different terminology that you use. Maybe we, grumble a little if it doesn't come on.
Or we have a blackout or something very rare.
Right. But we don't know all the reasons why it's flowing the way it is and the different meanings of energy. So this is great. I'm glad that you're going into this.
Yeah, hopefully it's helpful. I know we were talking about my grandfather had a farm in Nebraska, and a lot of the rural districts never really had electricity until around the FDR era, when they really went, and even during the 60s, Lyndon Johnson started to push for rural electrification. So it is a luxury that we enjoy, where we have this almost anywhere in our country today, not so in other parts of the world. So and we owe a lot of that to two people, Edison, Thomas Alva Edison, and Nikola Tesla. And it's an interesting story about how these two geniuses
I
really
love the story.
Yes, yeah, how they battled each other quite a bit. Initially, as we mentioned in the previous segment, Edison had formed the Edison Electrical Company, but he had also created a lot of other inventions and patents. The phonograph contributed to the telephone and microphone, and the motion picture industry. So through the years, this was just one of his many inventions, but it was probably the most important, the idea of creating a light bulb and then wanting it to make it available to everybody to light up the dark. So basically, he started this company up, and it was because it was funded by J.P. Morgan and the Vanderbilts. They went international, so they had generating stations. His very first one was in Pearl Street in Manhattan. That was set up in 1884. It served 508 customers with 10,164 lamps, and so that was an important, very basically breakthrough. Yeah, and it got the ball rolling. And steam engines were used to power generators. And we talked about electromagnetism just before the break a little bit about that, the relationship between electricity and magnetism. So the way you make electricity, one way is to take a magnet and oscillate it, or just kind of run it back and forth over a coil of wire. That will make electricity flow one way or another in that conductor. It's called inducing electricity, and so there's a lot of technologies like transformers and things like that that use that property of magnetism inducing electricity, and electricity, when it goes through a coil, when you put electricity through a coil, creates a magnetic field. So that those two relationships help us send that electricity long distances. But initially, with Edison, it was a challenge. He was using something called direct current, and basically when he created his generator to make that, it was sending electricity, but the wire itself that he was trying to transmit it over also has resistance. So he would start out from the generator with a certain voltage pressure that could push that current down, but if you got a certain distance, that voltage would start dropping. And so that was the problem with DC current at that time, and so they worked really hard at that. Also, to help him with his generators and some of his technology, he actually hired a young engineer out of his Paris facility, brought him over to America, and his name was Nikola Tesla. Mm-hmm. So he actually worked for Edison and was enthralled. He was fascinated by Edison and honored to be working for him initially, and actually was effective. He really understood more how to make generators work, and he came up with his own designs on the interplay of magnetism and electricity. And he fixed several problems for Tesla, both in Paris and then in the U.S. But I guess there was some falling out that in a private meeting, Tesla had offered him, or Edison offered Tesla a bonus if he came up with a better generator design, and so he did complete that, but instead of the bonus he got just an offer to get a raise and all that. So he was kind of upset with Edison. He kind of left the company. Unfortunately, in America, he didn't really know anybody, and there weren't any other really competing companies looking for his work at that time, so he wound up digging ditches for a while just to get by. Eventually, he showed some of his designs to George Westinghouse, who had a competing company, and his method used alternating current, and that's where a magnet is oscillating back and forth in the generator, and what's coming out of the generator, instead of a direct current going in one direction, it's actually going back and forth in two directions. But the ability of that wave, that oscillating wave, it could travel over a conductor without attenuating, without losing voltage at the other end. You could go much farther with an AC system, and because it was alternating, it could also jump the air, and that oscillating magnetic field, the current flow would also create an oscillating magnetic field. So that could induce current to flow in another coil wire that was spaced just across through the air, and you could actually induce current and use something called a transformer to boost the signal again, and then send it further down the line. So these transmission lines were really important. And then when it got to a station where it was going to be distributed to a household or to light up some lights, it had to be regulated and sent in and governed so that it just provided enough electricity without blowing out the light bulb or something like that.
Right.
So that's something that our modern utilities face every day today, and it's a real challenge. But in the early days, there was, around the turn of the last century, about over 100 years ago, there was a war of the currents. Edison really believed that his DC current was the best way to go, and he thought there were better ways to do it. Alternating current during the 1890s, other companies were using it also, besides Tesla and Westinghouse, and people were just throwing lines out there and trying to run current, just all over the city,
Yep.
Suspending in the air. They were like a mishmash of wires that were just going from building to building, and not very safely done, installed. We didn't have any of the standards back then, so people were actually getting electrocuted
Oh, my word.
from the AC voltage of the high wires. They'd be up on a ladder, they'd get knocked off the ladder, so people were getting killed. And so Edison really went on a campaign, and kind of backed by the Morgans and the Vanderbilts, to basically champion DC electricity, even though it had the limitation of not being transmitted very far. And Tesla, working with Westinghouse, pushed back, and they felt that their system, what was called the Tesla polyphase system, was superior in many different ways, even though it had this high voltage potential for hurting people. That it could be controlled and governed, and the benefits far outweighed that problem. So basically, during the 1893 World's Fair in Chicago, at the Columbia Exposition in the Golden Pavilion, Tesla with Westinghouse exhibited the Tesla polyphase system, and they used it to light up all the lights in the World's Fair. So that was a pretty good demonstration that this technology actually worked well. It had a combination of his polyphase generating system, it had transformers, it had transmission lines, and it had distribution stations that lit up all the lights. So we'll talk a little bit more about that war of the currents when we come back.